Lesson 17.3, Task 1. Mutually exclusive and inclusive events. Exploring probabilities involving mutually exclusive events. Two events are said to be mutually exclusive if both events cannot occur at the same time. For example, flipping a coin results in one of two mutually exclusive outcomes. It comes up either heads or tails. The Venn diagram shows the possible outcomes for selecting a random tile out of a bag of tiles numbered 10 through 30. Event A is drawing a tile with an odd number, and Event B is drawing a tile with a number that is divisible by 4. All right, so you can see here is A. This is your odd numbers, and again, we're only doing 10 through 30. And then these numbers are all numbers that are divisible by 4. So these two are mutually exclusive. They do not overlap because there are no odd numbers that are also divisible by 4. All right, it says make a two-way frequency table to show how many of the drawings are odd or even numbered tiles and how many are divisible by 4 or not divisible by 4. All right, so in the table, you have odd. So this is our event A, and then we have even, which is a complement. So your even numbers are considered your complement of event A. Then we have divisible by 4, which is our B event, or not divisible by 4, which is B complement. So this is again the complement of B. All right, so then you can see the table here, and you can see that there are 21 total events. All right, so it says, why is there a 0 in the two-way frequency table? So if you look here, this one says divisible by 4, and this one says odd. So again, it can't be both odd and divisible by 4. So there are no odd numbers that are not divisible by 4. There are no odd numbers that are divisible by 4. So this one is the correct answer. All right, it says find the probabilities of choosing an odd number tile, choosing a tile whose number is divisible by 4, and choosing either an odd numbered tile or a tile whose number is divisible by 4. So if you look at the probability of A is going to be 10 out of 21. The probability of B is 5 out of 21. All right, and then it has the probability of a union B, which means these two combined. Remember, union means you join the two together. So 10 plus 5 is 15 out of 21 events. All right, so how can you express the probability of choosing an even number tile with a number that is not divisible by 4 using symbols? All right, so if we look up here, okay, so we're going to choose an even number tile, and not divisible by 4. An even number tile and not divisible by 4. So that is this event here. So it's going to be 6 out of 21. All right, 6 and 21 are both divisible by 3. So 6 over 21, 3 goes into 6 twice, and 3 goes into 21 7 times. So 2 out of 7 is that probability. So that is A complement and B complement. And again, 2/7 is that probability. All right, what equation relates the values P of A and P of B to the value of P of A union B? All right, so we've got probability of A and probability of B, and then we've got probability of A union B, so we're combining those. All right, so what we're going to do, since these are mutually exclusive, that means they have nothing in common, That means if we want to combine or join these two together as union, we simply have to add these two probabilities together. So the probability of A plus the probability of B equals the probability of A union B when you have mutually exclusive events. All right, so explain why your equation relating probability of A and probability of B to this is true. Okay, so that's what I just explained. Since you have two events that you're adding together, a union means you're combining items from both events, and that means that you just combine those. So you're just going to add those together because, again, these are mutually exclusive, which means they don't share anything in common. So to add them together gives you your total for the probability of A union B. Okay, that's all for task 1. If you have any questions, let me know. Lesson 17.3, task 2. Explore probabilities involving inclusive events. Two events are overlapping events if they have one or more outcomes in common. Overlapping events are sometimes called inclusive events. Consider again randomly choosing a tile out of a bag of tiles numbered 10 through 30. Let A be the event of drawing a tile with an odd number, and B be the event of drawing a tile with a prime number. The Venn diagram shows the possible outcomes for the two events. So A, again, is your odd numbers, and B are prime numbers. All right, so you can see from the Venn diagram that all of these numbers are odd, but these overlap. These are odd and they're prime numbers. So this is called an inclusive event, where the others were exclusive. So these overlap and they have things that, are in common. All right, so make a two-way frequency table to show how many of the numbers are odd, how many are even, and how many are prime, and how many are composite. Remember, composite is the opposite of prime. Prime means it only multiplies by 1 in itself. Composite means it has other multiples. So like 6, for example, is a composite number. 6 is 1 and 6, or 2 and 3, so that makes it a composite number. So you can see up here, all of these numbers here on the outside, these are all called composite numbers. All right, so in our frequency table, we have odd numbers, that's our event A. We have even numbers, which is our A complement. Okay, so even numbers are the complement of odd numbers. And then we've got prime numbers, that's our B event. And we have composite numbers, which is our B complement. And altogether we have 21 events. All right, so why is there a 0 in this two-way frequency table? All right, so it says this is even numbers and this is prime numbers. So there are no even numbers that are prime. So none of the odd numbers between 10 and 0 are prime. None of the even numbers between 10 and 30 are prime. None of the even numbers between 10 and 30 are composite. So the second one is the only one that can be true. All right, find the probabilities of choosing an odd numbered tile, choosing a tile whose number is prime, choosing a tile whose number is both odd and prime, and choosing a tile whose number is either odd or prime. So again, you can get these numbers from the table above. So we want the probability of A, number of odd numbered tiles. So if you look up here, the probability of A, odd numbered tiles would be 10 out of 21. And then if you have prime tiles, there are 6 out of 21 prime tiles. And then it says the number of tiles that are both odd and prime. So again, these are odd and prime. So it'd just be 6 out of 21. And then union, A union B, number of tiles that are either odd or prime. So odd or prime, these are odd or they're prime. Okay, so that would be 10 out of 21. All right, so B part says, why is A intersection of B equal to the probability of B? All right, so why is probability of A union B equal to the probability of just A? All right, so if you look above, remember the intersection is where they overlap, and probability of B in this case is all the numbers that overlap because all of B is included inside of A. All right. All right, so let's see what we have here. So it says both of these equations are true because B is a subset of A. All right, what is the rule for mutually exclusive events of the probability of A union B equal probability of A plus probability of B not hold when events A and B are inclusive? All right, so if you remember from task 1, all we had to do to find the union was to add those two separate events together because they were exclusive. They were separate. That's not going to hold true here because if we add these two events together, we're going to get double for all the numbers that are included in B because B is included in both A and B. So it doesn't work the same when it's inclusive. So what equation relates the values of a probability of A, probability of B, and probability of A intersection B to the values of the probability of A union B for inclusive events? All right, so if we think about what equations relate, we know that the intersection is going to be just this part because all of these are in both of them, so that would be the intersection. And the union would be all of them together, but you have to subtract these from the second time because these are included in A and they're included in B, so you can't account for them twice. So let's see which equation would be best for that. So they all start with probability of A and probability of B. Now, are we going to subtract or add that part to it? So again, we have all of A, and all of A includes B, and then we're going to add a probability of B, and then what do we have to take out? We have to take out what accounts for B the second time because we just don't want to count that twice. So we're going to subtract A intersection B. So the part where they intersect, and that's going to give you your union now. So it's a little bit different than the last task we did, but that's the difference between inclusive and exclusive events. All right, that's all for task 2. If you have any questions, let me know.